Hello students, let us look at the next problem for discrete time Fourier series. This is a question, or this is a numerical that comes generally in most of the examinations. The periodic sequence is shown in the figure and we have to determine the DTFS and sketch the magnitude spectrum. So DTFS means discrete time Fourier series. So we have to find out the Fourier series of this particular sequence. Now in a way you can see that the sequence looks something like this. It's a square pulse, but obviously it is sampled. So when we look at it, we feel that okay, it's a set of impulses, but actually it's a waveform which resembles a square waveform. Okay, so it's a discrete square waveform which has a periodicity. Now if you look at the period of this one is going to start from 0 and going up to 9, because after that the next period starts. So from 0 to 9, how many values are there? 10 values. So the periodicity is 10. Okay. Now what we are supposed to do is we are supposed to find out the discrete Fourier series. We know that if we are having a signal x of n, the discrete Fourier series of x of n is given as dk, and I have written it as, I have put this particular symbol because with Fourier series you can find out what is the dk, and with inverse Fourier series you can find out what is x of n if you have dk. Now I am going to make a small change here, because in most of the textbooks instead of dk, sometimes dk is referred to as x, capital X of k. So it's the transform, it's the discrete Fourier transform from x of n to x of k. So now onwards I will not put d of k or dk, I will use instead xk. So you must be ready. In certain textbooks dk is instead written as c of k. In certain other textbooks it is having some other notation. So the notation may change, but generally it's kept as capital X of k. So we will find out for this particular periodic sequence the DTFS. Now what is the equation of DTFS? If we know we have a periodic signal x of n, then we can find out x of k as 1 by n naught, where n naught is the period of the periodic signal, summation going from n is equal to 0 to n naught minus 1. See, I am writing here n is equal to 0 to n naught minus 1. Sometimes in certain textbooks it is written as n is like this, n is within a range of n naught. That means you can start it from here and say that this is a period, or you can even start it from here, let's say from this point, and go all the way here and say that this is the period, because after that the same values repeat. So the period can start from 0 to 9, or it can even go from -2 to 7. Why? Because that same thing keeps on repeating. So n naught need not always start from 0 to n naught minus 1, but it can go from any value to a period of 10. Okay, so even though I write like this, from now onwards I can even write it like this. So it means that it is going from 0 to from some value to a value which is having a periodicity of 10. Okay, next we write x of n and then e raised to power minus j k omega naught n. Or if you already know x of k, then you can find x of n. This is the inverse. This is the inverse Fourier series. If you know x of k, then you can find x of n by writing straight away n, not n, k, sorry. this side it is k. So k is equal to period of n naught x of k e raised to power j k omega naught n. Getting the point? So you can find x of k, you can find x of k from x of n. That means you do the Fourier transform, that is Fourier series. Okay, or you can find out the inverse Fourier series. That means from x of k you can find out x of n, which is using this equation. This is something that we have done. I've just repeated here for the purpose of clarity. Okay, now how do we solve this? Now one of the method, okay, I will just write one of the method, which is very simple method, which is basically put the values. That means we want to find out x of k from x of n. So I will put, instead of n naught is equal to 10, the periodicity is equal to 10, and summation I am going to take from n is equal to 0 to 10 minus 1, which is 9. Okay, x of n e raised to power minus jk omega naught. What is omega naught? Omega naught is equal to 2 pi divided by n naught, which is 10, which is equal to pi by 5. So I can write k pi by 5 into n. Okay, k pi by 5 into n. Therefore I can write x of k is equal to 1 by 10 summation n is equal to 0 to 9 x of n. Sorry, I have to put the values now. So I will straight away open up the summation. You know that the first values from 0 to 5 we are having. So x of 0 e raised to power minus j k pi by 5 n. Now what is e raised to x of 0? X of 0 is 1. Similarly 1 is having a value of 1, 2 is also having a value of 1. So up to 4 we are having, all the values are 1. So I will now not write x of 0, x of 1 and all. I will straight away put the values. So the values is e raised to 1 into e raised to power minus j k pi by 5 n. Okay, n here is 0, so this is going to be 0. So 0 is e raised to power 0 is going to be again 1. So the first value turns out to be 1 plus, now x of 1 is 1 into e raised to power minus j k pi by 5 into 1. Okay, plus the next value is e raised to power minus j k pi by 5 into 2, which is 2 pi by 5, plus the third value is again 1 into e raised to power minus j k 3 pi by 5, and the last value is plus e raised to power minus j k 4 pi by 5. So these are the values of exponential values, or the values that we have, which now you can substitute using a calculator for different values of k. Now k is going to go from where to where? Obviously we have to find from x of 1 all the way up to x of 2, x of 3, like that we have to find up to x of not 10, x of 9, sorry, x of 10. We will start from x of 0, we will start from x of 0 and we will go all the way up to x of 9. Why? Because the period is from small x of 0 to x of 9. Now if you would have, instead of integration, the summation going from n is equal to 0 to 9, if you would have put the summation to go from, let's say, n is equal to minus 2 to 7, as I had previously told, then all you have to do is you have to calculate from x of minus 2 all the way to x of 7. So like that you can find out the different values using the calculator. Already I told you how you can find it out using calculator. You can just use 1 by 10. So this becomes 1 plus the magnitude of 1 angle of minus k pi by 5 plus e raised to power, not e raised to, again I have to write it in terms of polar. So 1 angle minus k 2 pi by 5 plus, like that all the way we will go. And then when we have to substitute for x of 0, then it is 1 by 10, 1 plus 1 angle of k is equal to 0. It becomes 1 angle of 0, which is actually 1 itself. So you will get 1 plus 1 plus 1 plus 1, like that you will get the values all 1. Okay, so 1 plus 1 plus 1 plus 1 all the way up to 5 values. So 5 divided by 10, you will get the value of 1 by 2. Okay, next again using calculator, if you want to find x of 1, then we will basically take again 1 by 10, and then for k is equal to 1 we will find out 1 plus 1 angle, now k is equal to 1, so minus pi by 5 plus 1 angle minus 2 into 2 pi is 4 pi by 5 plus next is 1 angle 2 into 3, which is minus 6 pi by 5, like that for all the values. Okay, so this you can find out using the calculator, and put the values. But again the values will finally, when you add it up, it will come as some real value plus some j imaginary some value. Okay, and like that you can find out from x0 to x1. Now this is one method that can be employed by you at any stage, it does not matter. But I will use the second method because most of the textbooks go for this second method, and it is important for you to learn this second method because it comes in the form of an equation. So let us see that. So I will show you the general method that is used for a square pulse. You have to use this only for a square pulse. Don't use this general method for a normal any other kind of a waveform. You can, but generally you use this only for a square pulse. Okay, why I am telling you this, because most of the textbooks also have this method, so they will be expecting this method to be used. Now for that we start with the equation of x of k is equal to 1 by n naught. Okay, 1 by n naught, which is basically 10. So I will straight away write the value. Xk is equal to 1 by 10. Summation is going to go from 0 to n is equal to 0 to 9. Okay, n is equal to 0 to 9. X of n e raised to power minus j k, omega naught is pi by 5 into n. Okay, now we know that x of n is having values of 1 from 0 to 4, and after that its values are all going to be 0. So what we can conclude from that is the summation will reduce from 0 to 9 to 0 to 4, because after 4 the values are all zeros. So there is no need to put add them up, because the value will anyway come 0 afterwards. So this I will change it to 4. Okay, and xn at those values are all 1. So I will again write this one as or what I will do is I will write it as a separate equation, otherwise. Okay, so I will write it as 1 by 10. Summation is going to be from n is equal to 0 to 4, and within those values the value of xn is equal to 1. So I am having e raised to power minus j k pi by 5, and n I will write it like this, the whole raised to power n, because it's one and the same thing. Okay, like this and this is one and the same thing. You have x raised to power, not x, let's say a raised to power n into m can also be written as a raised to power n the whole raised to power m. You can write like that, it does not matter. So that is the same thing that we have used here, and based on that, now this equation we are going to solve using a formula. This formula is, sometimes you might have seen this formula in arithmetic progression and all, that if you are having some value from n is equal to 0 to capital N minus 1 of some alpha raised to power n, this equation will have two kinds of output. The first is 1 minus alpha raised to power n divided by 1 minus alpha for the case when alpha is not equal to 1. When alpha is equal to 1, this value will come out to be n. That means for the case when alpha is equal to 1. Okay, so this is the equation that we will use or we will apply for this much portion. So it is as good as n is going to go from 0 to 4, and this much whole portion can be taken as alpha and raised to power n. So using this, okay, so using this, and this kind of formula will come again and again. In the next module you have these kinds of formulas which is very much used in for solving. Okay, so 1 by 10, and now within the brackets, so let me write the value. Now if I compare these two equations, what do I see? N is starting from 0. What about capital N? Capital N minus 1, capital N minus 1 is capital N minus 1 is coming out to be 4. Therefore n can be told to be equal to 5. Okay, so capital N is equal to 5 and alpha is how much? What is written inside this? So I will write 1 minus alpha, which is e raised to power minus j k pi by 5 raised to power capital N. What is capital N here? Capital N is equal to 5. So if I write that 5 and this 5 will cancel off. So it's as good as writing pi, only pi. So e raised to power minus jk pi divided by 1 minus alpha, which is e raised to power minus jk pi by 5. Okay. Now here I wanted to teach a technique. I want to teach you a technique which can be used by you in many cases. Suppose if you are having a value like 1 minus e raised to power minus j some theta value. Okay, which is, you can see in the numerator as well as in the denominator such a condition is coming. E raised to power minus j theta, here theta is k pi and here theta is k pi by 5. So you can use this for writing it in a particular way, and I will show that way. Okay, so this can be written as e raised to power 0 minus e raised to power minus j theta. Am I correct? 1 can be written as e raised to power 0. That e raised to power 0 can be written as e raised to power j theta by 2 into e raised to power minus j theta by 2. Why I can write it like this? Because if you multiply both of this, what will you get? E raised to power j theta by 2 minus theta by 2. And what is that? 0. Okay, so I am rewriting e raised to power 0 as this form. So I have got this minus, and again I am going to use for this one, I am going to write, so this let me put in the bracket, minus e raised to power, and this I am going to write it as minus j theta by 2 into e raised to power minus j theta by 2. I have split e raised to power minus j theta as two parts. Okay, so here again you can see that both these values, when they add theta by 2 plus theta by 2, will give me theta. So if that is the case, now from both of this a common value will come out. What is that common value? E raised to power minus j theta by 2. So e raised to power minus j theta by 2 I will take out as common. What remains is e raised to power j theta by 2 minus e raised to power minus j theta by 2. E raised to power minus j theta by 2, when I take out, I will get e raised to power j theta by 2 minus e raised to power minus j theta by 2. And with that, see here, I can divide this by 2j, multiply it with 2j. Okay, so what will I get if I multiply it with 2j? See, when I divide it with 2j, this whole function is the Euler's relation. You know, you remember that e raised to power j theta minus e raised to power minus j theta divided by 2j is basically what? Sine of theta. Here theta is theta by 2, so I can basically write whatever is in this bracket as sine theta by 2, and what remains is 2j into e raised to power minus j theta by 2. Correct? Okay. Now if this would have been plus, suppose if this would have been plus, this would have been plus, this would have been plus, here I would have put a plus, and instead of putting 2j, I would have put 2, and that would have made this, so here also into 2, that would have made this as cos theta by 2, and instead of 2j it will be 2 e raised to power minus j theta by 2. So I want you to remember this, and I will write it here. Okay, so e raised to power minus j, e raised to power, let me write it, e raised to 1 minus e raised to power minus j theta can be written as e raised to power minus j theta by 2 into 2j into sine theta by 2. Okay, let me write it properly. So 1 minus e raised to power minus j theta can be written as e raised to power minus j theta by 2 into 2j into sine theta by 2. Similarly, 1 plus e raised to power minus j theta can be written as e raised to power minus j theta by 2 into 2. So I will write that 2 in the front, so that is much better. So I will write it as 2 times e raised to power minus j theta by 2 into cos theta by 2. So these two equations, I would request that you should remember this of this particular shortcut. Some of you might already know this by using it in mathematics. Okay, so remember this particular equation. So using that, I can convert the numerator and denominator as, so I will write this. So I can get x of k as 1 by 10 within bracket, I can take e raised to power minus j theta by 2 into 2j into sine theta by 2. Theta by 2, here theta is what? Here theta is k pi, so k pi by 2. Okay, so I will write sine k pi by 2 divided by e raised to power minus j, here also I should have written pi by 2. Okay, k pi by 2, sorry, k pi by 2. Okay, and here also it will be, but k pi by 2 will become pi by 10 here, correct? Okay, into 2j into sine k pi by 10, which now simplifies as 1 by 10. 2j and 2j will cancel. Okay, and e raised to power minus j k pi by 2, I can write it as e raised to power minus j k, and from the denominator, if it comes up, it becomes plus, so I will basically write pi by 2 minus pi by 10. Okay, why? Because from the denominator I have brought it to the numerator, into sine k pi by 2 divided by sine k pi by 10. Now what is pi by 2 minus pi by 10? You all know it is 2 pi by 5. Okay, so I will write See, you can see that even though I took a lot of time to explain this, originally the solution of this is actually only this 3-4 steps. It started from here, isn't it? It started from, let me take the, yeah, it started from here, the general method, it started from here. I told about this equation. From here I put a substitution and I got straight away got the answer. Now here for different values of x of k, for different values of k I can find out different values of x of k. Okay, let me rewrite the equation. So now if I want to find out x of 0, if I want to find out x of 0, I will put the value 1 by 10 e raised to power 0, because k is equal to 0, so it becomes e raised to power 0. That should be 1, and then I am having sine of 0 divided by sine of 0, and we know that sine of 0 divided by 0 is 0 divided by 0. 0 divided by 0 is not solvable, so what we do is we use the L'Hospital's rule. So using the L'Hospital's rule, we will get d by dk of sine k pi by 2 divided by d by dk of sine k pi by 10. The 1 by 10 will be as is there. Sine k pi by 2 will become cos k pi by 2 into pi by 2 divided by cos k pi by 10 into pi by 10. So if I put 0 here, cos of 0 will become 1. Denominator also cos of 0 will become 1. So 1 divided by 1 will be 1. So what remains is 1 by 10 into pi by 2 divided by pi by 10 will become 10 by 2, which is actually 1 by 2. So x of 0 is 1 by 2. If you remember, in the first method, we again got the answer as 1 by 2 itself. So it does not matter whether you use this equation or the first equation, you will get the same answer. But generally, as I said, in most of the textbooks, the pulse waveform periodic equation is periodic sequence, the DTFS is basically found out by this method. That is why I am also using this method. Okay, x of 1 is equal to, now you have to put the value of k is equal to 1, so I will get 1 by 10 e raised to power minus j, k is equal to 1, so it is 2 pi by 5, which I can write it as 1 angle minus 2 pi by 5 radians. Okay, so you can find it out using this method, no need to find this, like you can find it out by using the polar method, into sine of pi by 2, which is 1 divided by sine of pi by 10, because that value is equal to, k is equal to 1. So based on this, we will get a particular value when I use the calculator. So 1 by 10, the 10 I will write in the denominator. Now e raised to power minus j 2 pi by 5, I can write it as 0.31, and the imaginary value is going to be minus 0.95 j, okay, minus 0.95 j divided by 10, because of that 10, to sine of pi by 2 is 1, so into 1 divided by, now sine pi by 10, so if I write pi by 10, I will get 0.31. Okay, now I can write this, I can basically write this as 0.31 into 10, I can basically write as 3.1 in the denominator, okay, 3.1 in the denominator, and I can even find out what are the further values. But see, if you look at the equation, they have asked you to plot the magnitude spectrum. Okay, what they have told is, they have asked you to find out the magnitude spectrum. Magnitude spectrum of x of k means you are trying to find out the magnitude of x of k. That means each value of x of k, you are only trying to find out the magnitude. Okay, so when you want to find out the magnitude of x of 1, there is no need for using the calculator, because the magnitude of this one is how much? 1. Didn't I tell you that e raised to power minus j theta, when written in polar form, it is written as 1 angle minus theta. So what is the magnitude here? The magnitude is always 1. So when you want to find out the magnitude of x of 1, the magnitude of x of 1 means you are trying to find out the magnitude only. So this one will have a magnitude of 1. So 1 divided by 10 into 1 divided by what we got previously, 0.31, which becomes 1 divided by 3.1, which comes out to be 0.32. Similarly, if I want to find out the magnitude of x of 2, the value will come as 1 by 10 e raised to power again minus j, k is 2, so 4 pi by 5, and then sine of k is 2, so 2 pi by 2 is sine of pi divided by sine of pi by 5, because k is equal to 2. Now here sine of pi is equal to 0, so this whole equation will have a value of 0. So magnitude of x of 2 is equal to 0. Similarly, if I want to find out x of 3, I will get the values as 1 by 10 e raised to power minus j, k is 3, so 3 into 2, 6 pi by 5, sine of 3 pi by 2 divided by sine of 3 pi by 10. Okay, so what do I get here? I will get 1 by 10 magnitude, then here also 1 is the magnitude, so 1 by 10, what is sine of 3 pi by 2? Sine of 3 pi by 2 is equal to minus 1, so into minus 1 divided by sine. So when I am trying to find out the magnitude, I have to find out the magnitude. So if I go for the magnitude of minus 1 is how much? 1. So I will just write this as 1 divided by sine 3 pi by 10, which comes out to 0.81, which comes out to be 1 divided by 8.1, which comes out to be 0.12. Okay, so like that you can find out all the way up to x of 10, and then you can plot it all the way up to 10, you can find out, and then you can plot it in a graph by putting the values. So x of 0 is something capital, this is x of capital K, capital X of K. So for 0, what is the value you got? 1, what is the value you got? All the way up to 9. So this is not up to 10, sorry, this you have to find up to 9, you have to find it out, and up to 9, whatever is the value you have got, that value again you will have to repeat it for 10 onwards forward. Okay, so you do that and see how the graph looks like. Basically the graph will have a sink kind of graph appearance, like sampled sink kind of, and then the repetition. Okay, so you try to plot and see how it will look like.